and now we would be recording. What I want to talk about here to start with is kind of some prior learning things. So some prior knowledge. So this course, Algebra 3-4, is an extension of your first year algebra course. So we'll start by me asking you guys what you remember doing in your Algebra 1 course. So I'm going to need for you guys to volunteer some things that you remember doing in your Algebra 1 course. And if you don't have the name quite right or you're not really sure what it's called, that's fine. We'll figure it out. I might ask you a follow-up question, but I promise I won't be mean about it, and I won't be trying to embarrass anybody. Just to kind of get a feel for where our beginning point needs to be. Okay? Yes? Great. So I think what you mean is like graphing the equation of a line. Yeah. So that's definitely an Algebra 1 topic, and probably one of the key topics in like your first semester of your Algebra 1 course. And one of the techniques you used to graph those lines was probably using the slope to count like over and up for the next point, right? That's probably kind of what you're thinking of? Okay. Justin? Great. Yeah, so factoring, probably in reference to quadratics. This is a topic that I kind of would guess that 50% of us saw, and maybe the other 50% might not have. If you took your algebra class as an 8th grader, this might have been something that you didn't quite get to, as 8th grade loses a little bit of time at the end of the year because they typically finish a little bit early. If you took Algebra 1 in a high school, I would expect you to have seen this topic. But we'll spend a lot of our first semester talking about quadratic functions and how to deal with them, factoring being one of the topics will be of particular interest to us, as it's maybe the single skill from Algebra 3-4 that is the most important moving forward into future math classes. And there will be some types of factoring that I'll expect you guys to be able to do quickly, like in your head, quickly and accurately. And there'll be other types that I'll expect that would require probably a little bit more thought and having to write some things down about. But this is a topic that we'll start assuming that nobody's really seen this before, although I'd expect that maybe half of us have seen this and to some extent or another. Tom. Tommy. Okay. So I'm going to write we'll do like basic math facts is what I'll call this. And by fractions, I assume you mean like add, subtract, multiply, divide fractions. And I'll include also like negative numbers is probably two things that you spent some time in your Algebra 1 course at least reviewing. It's not necessarily an Algebra 1 topic, but it's one of those topics that kind of every year needs to be touched on a little bit. And I think we'll probably do that in this course as well, at least in regard to the fractions, as I will present some methods that are maybe a little bit more general than like the shortcut methods that you probably best remember from middle and earlier high school to deal with fractions. The reason I would do that is that a lot of times these shortcut methods that you remember don't work so well if the numbers get quite large and don't work so well in future algebraic contexts. So I will probably spend some time reteaching some of these fraction skills in a way that seems less familiar to you, simply because it provides a really excellent foundation for a future topic that we will talk about in this class. So we can do the same thing with just some modification, but it'll be essentially the same procedures. So I'd like to start with something familiar to us like fractions before we start with the same procedure on something unfamiliar. But that's a second semester topic probably. But good. These are all good things so far. Who else? Caden. Yeah, so you were talking about solving linear equations. And then, like, for example, like 7 plus 3x equals 10 kind of things, right? That's kind of what you're talking about? Very good. Yeah, I would expect that everyone has done a lot of that in their Algebra 1 or prior to Algebra 1 courses. This is probably still even a, like, pre-algebra topic as well. You'll see a little bit of solving those kinds of equations maybe at the end of your pre-algebra course. But that's something I would expect us to be pretty good at. Good. These are all good things so far. Let's keep it going. Harley. FOIL. Sure. So those of you that don't recognize that term, that's an acronym for first, outer, inner, last. And it just describes how you would multiply out two binomials, like, say, x plus 5 times x minus 7. This is an expectation. Again, I would expect most of us to be pretty familiar with FOIL and feel pretty comfortable doing FOIL. But yes, great. That's absolutely an Algebra 1 topic that I would have expected us to see. Who else has some? So everybody probably remembers solving linear equations. Did anybody remember solving absolute value equations? Probably, I would guess that half of us spent some time doing that in your Algebra 1 class. If you took it as a high school student, I would expect that you did do that in your Algebra 1 class. If you took it in middle school, maybe, maybe not. But I'm hoping that you do remember a little bit of that. We will review absolute value functions and how to solve an absolute value equation for sure in Algebra 3-4. But that is something that I would hope we remember a little bit of. How about solving a quadratic equation? This is one that if you didn't get to factoring, you definitely didn't solve quadratic equations. If you remember factoring in your Algebra 1 course, you probably solved some quadratic equations. Probably not any quadratic equation quite yet, but you probably did a little bit of factoring to solve a quadratic equation. Again, that's a topic that if you saw it as a high school student, I would expect you would have seen a little bit of that. If you had your Algebra 1 course as a middle school student, probably not an expectation that I would have. But this is a topic that we would start from ground zero and do a very thorough job of covering this year. So if you don't remember doing that, that's okay. We'll make sure that you can do that this year. As these the first semester emphasis is going to be dealing with quadratics, so we will certainly make sure that we can factor and solve quadratics, as it's a very important skill into second semester and then really in future math classes. It's a very, very common problem type to kind of crop up inside of another more complicated problem. Good. Those are all good ones. There's another problem type that we haven't talked about. So there's another command term word that starts with an S that nobody's mentioned yet. So a kind of problem you would have done in your Algebra 1 course where the instruction is one word that starts with an S. Does anybody have an idea there? SI. Yes, very good. Simplify. I would expect that everybody has spent some time simplifying. And what we mean by simplifying is we mean add, subtract, multiply, or divide some algebraic terms. So like 5x times 7x minus 3x squared or something. And be able to simplify that into like a single term. So this again is something that I would expect that we've spent some time with. It's certainly something that I know that I need to take a little bit of time and review on, at least as far as the rules go of when we change the coefficients and when we change the exponents, just to make sure that we're all on the same page. Most students remember that sometimes you change one and sometimes you change the other, but don't exactly remember the rules for all of that right away. But that's something I would have expected we spent some time on in Algebra 1 doing problems like that. So we have simplifying, solving, graphing, some other miscellaneous things. And that's probably a reasonably fair description of what the big points from your Algebra 1 course probably were. You probably spent some time writing equations for lines even in there, but I'm going to not put that down. But that's because it goes mostly with the graphing part. So that's good. This course that we're going to be talking about today, Algebra 3-4, I'm just going to kind of give an outline of some of the major topics that we're going to look at and talk a little bit about the structure of the kinds of problems we're going to deal with throughout the year, just to give you a kind of a picture of where we're going, what the focus of this course is on, because the term Algebra 3-4 isn't very descriptive, right? Myself as as like a mathematics teacher, I've taken, I don't know, like 8 algebra courses over the course of my, time as a mathematics student. So it's like Algebra 2 is not a terribly descriptive topic, or descriptive title. We should probably do a little bit better job than that, and I think it would be helpful for all of us to have a little bit better idea of what we're really going to be looking at, or what's going to be important to pay attention to in this course. Okay? So the first thing that we're going to start talking about that's specific to this course is the idea of a function. This is probably a word that some of us remember from Algebra 1. Specifically, you probably remember using function notation on occasion, where you wrote like f of x equals instead of y equals. You kind of remember that? Sounds a little familiar. Here in this course, we'll create a more formal definition of a function and try to develop like a deeper understanding of what we mean when we talk about a function and the different ways we can represent the same information for any specific function. And then we'll talk about attributes that a function can have and the ways that we can describe that, which sounds very vague right now and very general and probably a little confusing. I will try not to do that. And try to present these things in a way that feels a little, very natural. But just like, if you were telling me about what your backpack looked like, you want some adjectives to be able to describe your backpack, right? You need to be able to talk about the color, or the size, or the shape, or the weight, or what it smells like. There's lots of different ways you could describe that, because the backpack has lots of different attributes, right? We'll do something similar for a function, is we're going to create a bunch of vocabulary that we can use to describe what this function is like to another mathematician. Does that kind of make sense? From here, we're going to spend some time talking about the following different function types. So as I teased earlier, we'll talk about absolute value functions, talk about quadratic functions, we'll talk about polynomial functions, and the polynomial functions are really a broader class of the quadratics, right? A quadratic is a type of polynomial. So we'll start with the more specific case of the quadratic, and then we'll build out towards a more general situation, which is a polynomial. So remember, the quadratics, the biggest exponent on your variable is a 2. Polynomial, the biggest exponent on your variable can really be as large as you want, but it has to be a whole number. So you could have like an x to the 10,000 in a polynomial. And that's probably the topics for first semester. Second semester, we'll talk about radical functions. And those aren't like surfer dudes at the beach radical, but instead we're talking about things that might involve like a square root or a cube root. Most of us should have used the square root a little bit last year in geometry when you did stuff with like the Pythagorean theorem and whatnot. You had to square root things. Might not have seen cube roots before, but I'm guessing from the name you can probably guess kind of what that's going to look like. But we'll talk about that in all due time. Kind of how that works and what that's like. Inside of this, though, we'll also talk about inverse functions a little bit more. We'll touch on inverses when we talk about functions in the very beginning, but we'll spend a little bit more time with that also when we talk about radicals. We'll talk about rational functions. And a rational function is basically just an algebraic fraction. So it's something like x plus 5 over x minus 3 would be like a rational, because we have variables in the numerator and denominator, or just one or the other. Then we'll talk about exponential functions. Yes, sir. Yes, absolutely. And some of you might remember talking about exponential functions in your Algebra 1 course. If you took it as a high school student, it's very possible that you spent a little bit of time at the very end of the year talking about exponential functions. I would find it really surprising as a middle school student, if you took algebra, that you got to talk about exponential functions, just because of the difference in the amount of time you have to spend in the course. And we'll talk about logarithmic functions. Those are the 4 topics in second semester that we definitely need to cover. Depending on how time allows, the next thing we would talk about would be sequences and series. Usually we get through some of that in this course, maybe not all of the series things, but we should finish the sequence things typically. If we manage to do both sequences and series topics, the last thing we would talk about would be some basic statistics. So those are kind of the tentative topics to cover. So if we were to describe this course, it's mostly a survey of functions. We're going to talk about what a function is, and then we're going to talk about these other 7 types of functions. For each of these 7 function types, what we're going to be mostly focused on is how we graph them, how we simplify an algebraic expression involving that type of function, and then how we solve an algebraic equation involving that kind of function. So inside of each of those 7 function groups there that I've outlined, those are the primary sorts of problems that we'll be looking at in each of those cases. The way I try to present this course is so that the techniques that we use to graphing kind of remain the same. We might have to make some modifications because of the differences fundamentally in the kind of function we're talking about, but I try to do the procedure similarly with the appropriate modifications, so it's not like whole cloth different every single time. Similarly with the simplifying and the solving. Again, I try to use a general framework, at least as my starting point, before going straight to shortcuts. The reason being, I want that same general framework that I can apply to any of these 7 cases, rather than memorizing 7 different shortcuts. If that makes any sense to you guys. My goal here is to try to stay away from lots of memorizing how to do things. Try to instead create like a general form that we can kind of always use that maybe fosters a little bit deeper understanding of what we're doing and rely a little bit less on the memorization. I will certainly present shortcuts and talk about shortcuts and how to use shortcuts and when to use shortcuts. But I usually want to present the most general situation that works all the time before I present the specific shortcuts that work some of the time. But that's kind of what this course is going to, what this course should look like or feel like this year. Do we have any questions kind of about that? Do we feel okay in terms of the things we talked about as prior knowledge that I said I would kind of expect that you remember how to do versus the things that I'm like, it's okay if you don't remember this, we're going to do this again? So on that same topic, what I'd like to say is that we have a bit of flexibility in this course in terms of the pacing. I would rather go a little bit slower, miss a few of these topics at the end to make sure that we understand what it is that we're doing and we're doing a good job with it. Now, there's a limit to how slow we can go. But I would appreciate from you guys if while we're doing something, if you have an issue, like you said something I don't understand, or I feel like I'm missing something along the way, that you speak up so that I can slow down, that I can re-explain things, that I can take a little bit more time to make sure that you guys understand what's going on. And I'd really encourage you not to wait until things get really fuzzy, as it makes it that much harder to kind of sort out what the problem is. And I know that sometimes my vocabulary is kind of precise, and I might be using some technical math terms that you're not really familiar with. If that happens, stop me, ask a question about what do I mean when I say, blah, 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 blah. And we can talk about what it means. And do some specific examples to kind of hopefully get you a little bit of intuition or a little bit of feeling for what it is that I'm talking about. But it's really important, especially early on in your math course, the very beginning of the year, that we get on the same page rather quickly, and we don't let a little problem become a big problem. And I understand that in these regular algebra classes, many of you are students that don't particularly like mathematics and come in with a little bit of baggage about your feelings towards the subject. I'd ask you to try to give me the benefit of the doubt there, is I really want to try hard to make sure that this is something that's doable for you, that you feel like I'm giving you the information that you need or the explanations that you need to understand what it is that we're doing. And if it's a situation where you really feel like you're starting from somewhere and I don't know anything about that somewhere that you think is the starting point for me, that you let me know on that. So if there's some prior stuff that you're just like, I don't know anything about whatever it is that you're talking about right now, that you communicate that to me so we can fill in some of those gaps. And if it's multiple of you, I'm happy to do that kind of thing even during class. If there's a large number of us that are like, yeah, I need to do the fraction stuff again, or I need to do, like adding or subtracting negative numbers again. Like I just need to see it one more time because I still feel fuzzy on it. So if you are having problems or there's some stuff that you think is like, it's like I know I should know this and I feel stupid for asking it, like you gotta get over it. Like the feeling stupid for asking and just ask it. You won't be the only one that doesn't remember. Okay? It doesn't make you dumb to ask questions. It's dumb to sit there not understanding and pretend like you do. Right? That's the dumb thing to do. So, and I don't mean smart and dumb. Like, you guys know what I mean though, right? Like it's not helpful to pretend like you understand what's going on when you don't. Maybe that's the more polite way of phrasing it.